Hello everyone, thank you very much for joining me in this new lesson from the Spring Security Fundamentals new playlist. Today we start discussing about OAuth 2 and OpenID Connect. I have to warn you from the very beginning, this will be more of a theoretical lesson, because before going into coding the components related to OAuth 2 framework, I would like to make sure that everyone is aware of what we are going to do. So I don't want to step into writing code, using the new authorization server, implementing the resource server and stuff like that before you guys understand properly first what is our goal. So today we are going to theoretically discuss about what OAuth 2 is, the grant types, tokens, everything that is really important. Some of the things we are going to repeat while we are working on code, but today we just get started. So in case you already know this stuff, maybe you don't want to get bored with me here. If you don't know them, however, it's really important you understand these things before. So guys, you already saw we have a live chat there, so if you are live here with me, you can leave your questions and comments in the live chat. I also say hi. If you are watching the lesson recorded, you can still ask your questions in the comment section. That being said, let me actually share my screen and start discussing about OAuth 2 and OpenID Connect. So imagine this situation. You have an application, users of course use it. It can be a web app in a browser, it can be a mobile application. I just designed it here as a web browser because it was easier, but just think about it as any kind of application. It can even be a desktop application. And imagine this situation. The application has a front end and the back end. Have you ever found in real world cases where you have front end and back end? Of course, probably most of them have a front end and the back end, whatever technologies are used. Now, the problem is, or it's not necessarily a problem, but the idea is that most users tend to use multiple applications. So each application, of course, has its own backend and frontend. No, so if you use multiple applications, then what happens with the security in this case? Do I, as a user, have to register and have a password and a set of credentials for each application? And of course they should be different. Then I need to memorize them, or I need to use something like a vault or a password manager and stuff like that. But it's pretty much difficult. And when you have multiple applications, to have users and passwords for every one of them, and try not to mess with the credentials from one to another. And in an organization, maybe it doesn't even make sense, isn't it? Because you are still recognized as the same individual for every application in that organization. So maybe when we discuss about having a set of credentials for Gmail versus Facebook versus Twitter, maybe it makes sense because they are totally different organizations and you are just a public user outside of them. But when they are applications designed for the employees of an organization, then it might not really make sense to force your employee memorize 10 different set of credentials, or even more if you have 10 different set of applications. So in that case, instead of having the user with the credentials in each and every one of the applications they have to use, you separate the management of the users in a different application. And let me actually call this different application from now on the authorization server. Okay, so this is the authorization server, and this is one of the main actors of OAuth 2. And what you see here, actually, they are the four main actors of OAuth 2. They are the user, the client, the authorization server, and the application's backend, which formally in OAuth 2 and OpenID Connect we name resource server, because that's where the resources are managed, but that's simply the backend of the application. So when you hear resource server, that's the terminology, but it's just the application's backend, okay? So nothing more. This is the client, is the application's front end, whether it is an application or a simple, I don't know, React, Angular, something front end, or it's a desktop application, we call it the client. And it's the front end, and then of course you have the backend, but we don't call it a backend, we call it the resource server. So first of all, now you know, if you didn't already, you might have already known how these are named, but it's very important to start from the beginning and make sure that you guys really understand very well this framework before diving into coding, because what I find very often, and that's an advice from my side, especially when dealing with frameworks that are not necessarily easy, I see that people tend to try to step directly into one specific subject that seems more, I don't know, useful, cool, or they simply need that one at that moment, and they try to skip the fundamentals, and then they don't understand. And at some point, actually, I had a question, someone was asking me how they do something with JVT, and I figured out actually that they didn't even know what JVT is. And I asked them, okay, you don't know yet what JVT is, but that's not a problem. Just go back, make one step back, go to the fundamentals, learn the fundamentals, and then go back to the JVT chapter, because otherwise you will not understand. It's going to be frustrating and you will end nowhere. And even if you end up creating something, you might end up creating that something in a wrong way. So I do advise you that's why I'm now starting with the fundamentals even with this, because I do advise you always make sure that you really well know step by step and don't have holes in your learning. So is it correct to combine authorization server and resource server in the same web server? Well, theoretically, these are only roles. So this is a role, this is a role, this is a role, this is a role. What does that mean? Is that even all of them, they can be inside the same application. Well, it doesn't really make sense to have a client and the resource server all together, because then you don't have a front end and a back end. And it doesn't really make sense to have a client and authorization server all together. But maybe some of you thought about having the authorization and the resource server all together, and sometimes it happens. It's not wrong to have both roles in only one application, but you have to be very careful, because you are always making compromises from an architectural point of view. So remember, you put them together instead of splitting them apart. It will be more difficult for you to scale the applications horizontally. So this is more this is more like an architectural question. Can we put the roles or not together? Technically, yes. Practically, you have to be very careful if you do something like that. So this is my answer. It really depends on what you are implementing, if it makes sense or not to put them together. In most cases, I found them implemented apart, and for me it makes more sense that they are apart rather than in the same application. Can I call a single app like an API which serves as a gateway app a client? Yes, you can actually, even a server, it can even be a server side, or it can be even a totally different application, like for example Keycloak, or like for example Kubernetes, or an orchestrator, or something like this. When you will need actually a totally different backend to call your resource server, and then that will in that case become a client for your system. So when I say client, I will demonstrate it here, and in most of my examples I will use just a simple idea of having a React or Angular app in a browser, but it's generally any application that needs to call or use a resource on the backend. And usually resources, the way we think about them nowadays, they are simple APIs or endpoints that we call. Cool. So what happens is that now I don't want to have the users in my resource server or in every application individually managed. So I take them apart, and I put them in a separate so-called system or component that we name the authorization server. So how does it work? How will, in that case, my client be authenticated and the user, in case it exists? And by the way, one important thing is that the user in this framework is not mandatory. So we'll discuss situations where the user doesn't exist as well. There are grant types, how we call them, where the user doesn't exist. But let's say in this case, the user wants to use something as part of their data, maybe some API, something through the client. So how does it work? Well, it works like this. Whenever the client needs now to access something on the resource server, the client will have to first make sure that it gets the privileges. In case it's about a user, it even has to make sure that the user authenticates. So the client is responsible to authenticate itself in case that's needed, or authenticate the user in case we are on a situation where we have a user. So what happens is that when the user tries to do something here, of course that arrow didn't work, but okay, my tool doesn't want to work now. No problem, I will just draw it like this and you will for sure understand what I'm doing here. So when you have a client, okay, and the client tries to use something, get some data, the client makes sure itself and the user gets authenticated against this application that we named the authorization server. And I will come back later with this part that we call getting a token through a grant type. And then assume everything goes well, and the client gets the token. So that's what happens here, the first step. Then the token acts like an access card. It will allow the client to open doors in the resource server. So the access card, of course, will not have always all the possible privileges, but it will have the privileges according to what was allocated to that specific user or client, depending on the case. So the resource server, through the token, will be able to identify who is making the request, and then the resource server will actually apply the authorization rules. So you see, one funny thing about the authorization server is that it actually makes the authentication, and then it provides enough details through the token so that the resource server can apply the authorization rules, but the authorization rules are still applied at the resource server level. So when we will build such a system in the next episodes, what will happen is that we will get a token, but you will still see things like the authorization rules through the filters or through pre-authorized, post-authorized, and so on. They will be on the resource server side, implemented with Spring Security. So here is at the resource server where we apply the authorization rules, meaning everything you learned about matcher methods, about pre-authorized, post-authorized. See the previous lessons in case this doesn't sound familiar to you yet. We discussed them already in the previous lessons. And the authorization server's purpose will only be to manage the users and the clients. So it will manage the details about the clients and the users who tend to access data or actions on the resource server, so-called resources in a generic way, and provide the token in case the authentication succeeds. And the token itself needs to contain or get access through it to all the needed information for authorization. That's how it works. So you can imagine as an analogy, and with this I will end the explanation about the architecture, and we go to the next step, which is step 1, getting a token. is you go to an office building. You are not employed there. Maybe you have to, I don't know, attend an interview, or you are simply a visitor for someone. So what do you do is you go to the front desk, you identify yourself, and you get a card. So that's exactly how the authorization server works. You go to the front desk. This is the front desk. The front desk somehow identifies you, for example, in your case, via your ID token, so it does the authentication, and then you get a card. That card will allow you open some doors in the building. It will most likely not allow you open all the doors, but that's basically exactly how the token contains the privileges and based on which the resource server, which is the office building, will apply and will give you the right privileges in that case. So are the REST APIs which I want to protect reside on resource server or separately? So they are on the resource server, remember, and I said that from the very beginning. The resource server is just a formal name of saying backend, okay? So the APIs, they are the resources. This is the backend, and the APIs plus data plus blah blah blah, these are resources, okay? So yes, the APIs, they are the resources, and yes, they rely on the resource server, and they are protected by the resource server with exactly the things we learned in the previous lessons. So you will see me in the next lessons when I'm building a resource server, I will literally use everything you have already learned in the previous lessons. So it's very important you know what we discussed in the past lessons, okay? So that's how it works. Now we can go to a next step and identify this as, say, from the OAuth point of view. Step one is, how do we get a token? So this is step one. That's the first thing you need to learn, getting a token. And that's the first thing we will start with next time implementing. And then you have the second thing. And the second thing is, how does the resource server know that a token is valid, and how does it take the information to apply the authorization rules? So 1 and 2, these are two things that you need to learn, and that's what we are going to discuss. So how does the client get a token? And here we'll discuss about grant types. Secondly is, how does the resource server backend, okay, to avoid any confusion, validate and get data with the token? And if you learn these two steps, then you have learned the most important things about OAuth. So how do we start? Let's start with the first one, the grant type. So I'm going to leave this diagram the way it is, and then I'm going down below and I'm going to put these actors in the shape of a sequence diagram. And I'm going to discuss about the most important, the most basic ways in which a token is obtained, okay? So I'm going to skip the resource server because in the end, after you get the token, the resource server will be just the last step where the token is used. What we are interested in now is, how does a client get an access token? And we have to discuss about several ways in which a token can be obtained. And these several ways, they are called grant types. And we have, I recommend you know about at least 2 important grant types, 3 if we want to put the refresh token. So it will be the authorization code grant type, it will be the client credentials grant type, and eventually, but it's a little bit of a special one, the refresh token grant type. So besides this, we have also, and you will hear about, the implicit grant type, the password grant type, also known as the resource owner credentials grant type. They should not be used anymore. So I'm not sure if I can strike it out somewhere here. I don't see where I can strike it, but you remember, so I can just write here, deprecated, do not use. Okay, so do not use. Good. So we are only going to discuss about the authorization code, which is the most important and the essential one used when you have a user, the client credential, which is the one you will find immediately you use to get a token when you don't have a user, and you have the refresh token, which is a special grant type you can use together with the authorization code to obtain a new access token in case you don't want to have the user re-authenticate themselves when the access token is not valid anymore. So also we'll have to discuss about the authorization code with PKCE, and I'm going to take all of them one by one now. So let's start with point one, the authorization code grant type. So what you need to learn here is how does it work from the moment the user wants to execute something up to the point we get a token. So it's pretty easy. The user says to the client, well, I need to do that, which that is an action that requires authentication. Of course, assuming that we don't have a token yet, then the client needs to get a token. So what does it do? The first thing the client does is redirecting the user to a login page in the authorization server. Okay, try to draw it. And okay, so redirecting the user here to a login page. Just assume we have a login page. In this case, the authorization server needs to have a way the user can authenticate, so a so-called login page. So this is the login. And this is where the user will put their credentials. So what happens on these lines? This is the user's request. They say, I want to do something. So I want to do something. And this is where the client redirects the user to the login. Pay attention, very important is the login is not something designed by the client, but something that is directly on the authorization server side. Otherwise, if it were something designed by the client, we would have been on the password grant type that is deprecated and you should not use anymore. Okay, so it's very important to remember that the user logs in the authorization server. Once they log in, what happens is that the authorization server redirects in browser back the user to a page in the client. So how does the authorization server know to what page they should redirect the user? The authorization server first of all has to have that URL registered, and secondly, the client sends it here when it redirects the user to the login page. It tells also the authorization server when the user logs in successfully, please redirect them here to this page. So this is what we call the redirect URI, and the redirect URI is provided by the client and needs to be known previously by the authorization server. So it redirects the user back in browser to the URL provided by the client, and here is where we have a key that we call the authorization code. So the authorization code is kind of a password, kind of a secret that the authorization server shares via this redirect with the client. And this is actually why the name of this grant type is authorization code. You see it here. So we name it authorization code because that's the first thing that the client gets after successful authentication of the user. It gets the authorization code, and then with the authorization code and by identifying itself, the client makes a post request and gets the access token back. And on this post request, it provides the authorization code, and also it's a must, the client needs to also authenticate themselves. So authorization code goes here together with the client credentials, and then back we have the access token. Okay. And that's it. This is the first flow, which is called the authorization code flow. So I see another question. Does that mean that there are two login pages? No, there are no. Where do you see two login pages? There are no two login pages. When the user has to do something, this one doesn't have any login page. There is no login page here. The client simply redirects it in browser to the only login page that exists only here at the authorization server side. Okay. The redirection between client is implicit. Yes, it is implicit. So that's what I meant. So there is only one login page. The user must put their credential only in a page provided by the authorization server, never on any page provided by the client. And then it gets the access token. Okay, now we have two flavors. The first flavor is the one that I told you now, I explained it now, when the client here using the authorization code, but also its credentials. So the client credentials. Okay. Yeah. Anyway, you got it. So the client credentials, which I would like you not to confuse with the user credentials. So the client credentials, we call them client ID and secret. And they are a set of credentials, username, password, but they identify the application. While this is different than the username and password, which are the user's credentials. Okay, so don't make a confusion between client credentials and user credentials. Both of them are known and managed here. So the authorization server manages both user and client credentials. And next time we will have to implement that. So it's very important to remember this. Okay. Okay, so this is the client identifies themselves, gets the token. Okay, so what is the whole thing with PKCE? The whole thing with PKCE is that, you see, the client credentials are not that safe in the end, are they? Because the client needs to store them somewhere, but the client is something public, like a web page. So it's very difficult to keep some credentials very safe. Of course, that's not a big deal. In the end, they can be kept safe enough. So that's why the authorization code without PKCE have been used. It's still being used. And sometimes, especially when we discuss about non-public clients, it's still a way that, I don't say it's recommended, it's accepted. But recommended, it's always, from now on, you use PKCE, which is a very simple concept actually. The concept is we use something else to identify the client instead of the client credentials here. What can we use instead of the client credentials? Well, we do like this. When this redirect needs to be done, the client generates two pieces of the information. One we call a challenge, and the other one we call the verifier. So the challenge is a simple random piece of information, while the verifier is a hash over that random piece of information. So remember, this happens at this stage when the redirect happens from the client to the authorization server. Okay. Now, however, even if both pieces of information are generated here, and I think I put them the other way around. They should be challenge and verifier, but anyway, it doesn't matter. The idea is the same. The hash, remember, the hash is applied here to this code. Okay. Now, what do we know about hash functions? Again, if you are going back to one of the previous lessons where we have discussed that a hash function has no reverse. Remember that? So when you hash something, you go from an input to an output using some cryptographic function that always allows you to verify the input to the output, which is called the matches operation. But you can never go back from the output to the input. If you have the output, you can't get the input. So what happens if someone intercepts this redirect here? Can they get the hash of the random value? Yes, they can. Can they use it for anything? No, they can't, because they can only see the hash. They can't see what value has been hashed. But what's the use in the end? Well, the use is the following. The hash is sent via this request and the authorization code is received by the client. Now, when they have to authenticate here, instead of using the client credentials, they use this random value here. Okay. And let me actually put them the correct way. Okay, so they provide the random value here. And that's the way they prove that they really are the client who redirected initially the user, because it's only them who can know the random value, because the random value never left the client. The random value never left the client, only its hash left the client. So now it's very easy for the authorization server to validate. They have the hash and now they get the random, and they use the matches method to validate that the random is indeed the input of that specific hash. And that's what we call the authorization code with PKCE. And it's very valuable. Specifically this flow is very valuable because, as you can see, we don't need to use client credentials anymore. We don't need to use a secret anymore. You can combine them, that's fine, and usually we do that. But the idea is that now if someone would manage to steal somehow your client credentials, they can't get an access token. They would only be able to get an access token if they really need the random value, if they really know the random value here, but that's it's unlikely, it's impossible to get. Okay, so that's one of the most important grant types that you need to remember. So this is the authorization code grant type, which you'll probably always discuss about when implementing OAuth 2, because in most cases we have users and we need to authenticate them somehow. A few more questions. So is login page provided by OAuth providers which are configured like Google, Facebook? In case of Google, Facebook, they are the authorization servers. Yes, you log in through them always and then they redirect you back, so it works the same way. Do we have any Swagger-like API docs for OAuth 2? I'm not sure exactly if I understand the question, but we do have, and you will see it next time, some endpoints that we call the documentation endpoint for OpenID Connect, which is a protocol over OAuth 2, but that will be next time, okay? Is random generated dynamically using PKCE algorithm at runtime? So these two are generated every time for every call exactly here, okay? So exactly here. They are generated, is not one time, it's per every call, okay? And then OAuth server needs to know the hashing function type, though. Yes, that's why, as you will see, and that's a very good point, you will see that when we send the random value here, or actually when you send the challenge here, we also specify, and you will see next time when we implement it, you see that it says S265, for example, if we use SHA-265 and so on, 256 and so on. So it needs to know, and is the client who tells them what hash function they used. But that's a very simple point, isn't it? Cool. And that's basically, hopefully that clarifies the authorization code with or without a PKCE. If that's clear, I would like to make one step further. So this is the authorization code. Okay. Authorization code. No, I don't know. My computer doesn't want to cooperate with me. Code, grant type, and then I would like to go one step further and discuss also the client credentials grant type. Okay, so let's take these two. And then you might wonder why we don't have a user. Is because the client credentials is called client credentials for a reason. It's actually when we have a service and there is no user who needs to authenticate and only a client. So imagine any situation where you have a service, like a different backend component that has to authenticate for another one, it becomes client for that resource server. Another case is maybe you have something like Kubernetes or maybe Istio, a service mesh, something that helps your application run, and they need to call some endpoints on your application server. They need to authenticate, but there is no user there. It's only Kubernetes or Istio or Datadog, or I don't know, whatever monitoring tool you are using. So how can you implement, where can you implement the case where you don't have a user, such as this case where another software is just a client needing to get some access to some APIs? Well, in that case, we use the client credentials. Client credentials is very, very simple. When you implement the client credentials, the client sends the request using its credentials and gets back the token. So this is literally a 2 arrows flow, nothing special here. Very simple to understand, okay? But what you need to be very careful here is that you don't allow for all the endpoints the client credentials. So, okay, you have client ID and secret, and then you get back the token. Okay, so what you need to make sure is that if you have endpoints that are implemented to allow being called with client credentials, you somehow identify the client and you make sure that only those endpoints can be called with a token that has been generated using this grant type. Because imagine what would happen if you don't take that into consideration, and then you have both authorization code grant type and client credentials grant type, but you basically allow all the endpoints being called with a token no matter the way it has been achieved. Then it makes no sense, because it's actually a very, very critical vulnerability, because someone who knows that might actually get their hands on the client credentials or on some client credentials, and then get a token without needing a user to authenticate, which is not something you'd like, is it? Okay. I'll talk about tokens and having them in the database later, so please bear with me. So this is the client credentials, and then the third one that I would like you to know is the refresh token. Which refresh token is very easy also. So what is a refresh token? A refresh token is a value that you get in the response after the user authentication. And the purpose of this value is to allow you to regenerate a new token without having the user authenticate again on the same session. So in this case, we still have a user, but they have already authenticated via the authorization code grant type. And now the client has what we call a refresh token that has been obtained in the response of the authentication. So what happens in this case is when the user, okay, no more space on my document here. Okay, when the user tries to get something, okay, they try to get something, and the access token is no longer valid. So normally if you don't have a refresh token, then the user should go again through the whole process that we discussed earlier, which is the authorization code grant type. But what you want to avoid is to have something like a 15 minutes or 20 minutes lifetime of a token and ask the user log in again and again every 15, 20, 30 minutes, because that's, well, it's annoying. No, you would not like to have your application log you out and ask you re-authenticate again and again. So instead you have the refresh token, and the application memorizes it and it sends the refresh token, and if the refresh token is a valid one, then the authorization code will send back a new access and refresh token back. So okay, you will have back a new access token and the new refresh token. And then the app can do that again and again, okay? So this is where the refresh token goes. And then what it gets back, it's a new access and the new refresh token. Very easy. And then the new refresh token can be used to get a new access token and the new refresh token, and so on and so forth. And of course you can make them expire, and you can make the refresh token expire as well. And if the refresh token expired, then mandatory the user needs to log in again. But you avoid, like, at least on the time, on the lifetime of the refresh token, you can avoid forcing the user to relog in. Okay. Good. Can frontend send user ID and secret plain text to backend? I hope you mean client ID and secret, because user ID and secret, they are never known by the client, okay? So remember that username and password, they are never received by the client. So if your question is about this, my answer is no, because anyway the client doesn't know them, so they cannot be sent to the backend. If you were talking about the client ID and secret, however, then the answer is yes, they are basically sent usually as HTTP basic, so that means base64 encoded, and hopefully you are using HTTPS, okay? But remember, only these are known by the client. These are not known by the client. Always the user logs in the authorization server. So these are three essential ways in which you get a token, meaning the client gets a token so they can get authorized. This is step one. If you remember these three grant types and how they work, and you know that the result is getting an access token, and that access token is then used to get authorized on the backend side, that we also call the resource server, then you have already learned half of the things. Now, to go further to how does the resource server validate the token, I would like first to take a few minutes and discuss what tokens look like. Because there is quite some confusion in the world out there, believing that token means JVT, which is not right. JVT is only one implementation of a token. JVT is just the implementation of a token. So it's just a token implementation. Actually, the tokens, we qualify them into opaque and non-opaque tokens. And opaque tokens are by definition, opaque tokens are by definition tokens that don't contain any data, while non-opaque tokens are tokens that contain information inside. And in case you didn't guess, JVT is an implementation inside, data inside. JVT is an implementation of a non-opaque token. JVT, which stands from JSON Web Token. By the way, JVTs can be signed or encrypted, but I will give you more details about that also in the next lessons. Now let's just stick on the fundamentals. So, first of all, JVTs are not the only tokens that exist out there. Actually, in the OAuth 2 framework specification, there is even no specification on how a token should look like. A token can be a random number. A token can be a UUID. A token can be a JVT, can be something else. So it can be anything, actually. A token can be anything. But in the end, that token should help the resource server apply the authorization rules. So let's start actually with discussing opaque tokens. Because opaque tokens, they don't contain any data. And my opaque token can look literally something like this. Okay, this can be a token. It doesn't contain anything. It's just a string known by the authorization server. In that case, and in the case of the opaque tokens, the authorization server will always implement a so-called introspection endpoint. The introspection endpoint is an endpoint that gets a token and returns details about that token, meaning not only if the token is valid or not, but also information, relevant information about the client and the user that will be used by the resource server to apply the authorization rules. So if you say that you use Opaque tokens, it means you have an implementation where you get tokens, the client gets tokens that don't contain values inside them, but they can be used to call the introspection endpoint to get the values. So in that case, the resource server will always introspect the token and get the needed values to apply the authorization rules. While if you have non-opaque tokens, and I will stick to JVT here because it's actually the only implementation I have ever seen as non-opaque tokens. Not that you can't implement your own. You can implement your own kind of tokens. You can create your own token based on XML if you want. So that's fine. But let's stick to JVT because that's basically what you will see also in the examples. What is the difference between Opaque token and ID token? ID token is one of the tokens you get in the response, while Opaque token is a type of token. You can compare them. But let me tell you about ID token and what that is when we discuss OpenID Connect next time, okay? Because ID token is something specific to OpenID Connect. The ID token can itself be opaque or non-opaque. Okay, so we have the JVT, and the JVT, unlike other tokens, and oh, I already have a browser here. I would like to show you how it looks like. It's not only any piece of string. It's a base 64 encoding of a JSON. It's composed of 3 parts, where the third part is actually a signature. In that case, what happens is that this third part, called the signature, is offering security over the header and the body, which contain the information, but also on the token itself, proving that it has been indeed created by the authorization server. Because in case the token is it's an opaque one, for the resource server it's very easy to find out if a token is valid or not. If the token is not valid, then when the resource server calls the introspection endpoint, the authorization server will simply tell them, I have no idea what this token is, and then it's not valid. But in case of a non-opaque token that contains information inside, what happens is that the resource server will not call the authorization server anymore. It doesn't need to do that. Why? Because the token is signed and the resource server will be configured with a key that can validate the signature. So in that case, the client gets the token, it sends the token to access the resource, and the resource server will simply validate the signature and directly get the information from inside the token itself. So we'll have all the information needed in the token. It will not need to introspect that token anymore. And that's basically step 2. Depending on what kind of token you use, you will either have to use introspection or you will use a cryptographic approach. There is a third way called blackboarding, but I would like to skip over that because it's something that you will rarely see in real-world examples. So let me skip over the blackboarding approach, and I will only discuss with you the introspection and the cryptographic approach, which are the most common ways. So can you please make a serious video on OAuth 2 with Spring Auth server, please? But what is this actually? This is a series on OAuth 2, just that today we started with a theoretical example. The next episode will be exactly on that, Siful. So thank you for the recommendation, but it's already on the list. Next week you will learn that. I hope you will be here and you will enjoy the session. I guess that's it with the basics. So I don't want to go deeper. I wanted to cover all the fundamentals. I don't want to get you all too bored, because I know theoretical sessions is not something you really like. But next episode, next episode, we start with implementing the authorization server. And then everything that we discussed today will be important and useful, because you'd like to really well understand what we are discussing, okay? So we will continue with implementing the authorization server in the next lesson. And then, of course, with completing our system with a resource server, and eventually, why not, even implementing a client with Spring, which is something that you see more rarely, but it's still something that you can do. With that being said, guys, thank you very much for being so many here with me today, and I really hope you enjoyed and you found this lesson useful, even though theoretical. It will really help you at least next time. If you didn't know this, it would have been more difficult next time for you. Next time we will dive into practically writing code using the new authorization server and the latest, of course, Spring Security versions, and that's basically everything for today. See you next time, and until then, I'm waving goodbye. Have an excellent time for study further, and cheers!